this video, we will use logarithms to write the inverses to some basic exponential functions. So let's start by looking at the function f of x equals 7 to a power of x, where y equals f of x. If this is the case, then y is equal to 7 to a power of x. So x is the exponent on a base of 7 needed to produce a result of y. So if we rewrite this in logarithmic notation, we have x is equal to log base 7 of y. Therefore, x is actually a function of y, which means that f has a function inverse. So recall that if we have a function inverse for f, so we have f inverse, then we will switch the inputs and outputs of f. So by that I mean the output of f will become the input of f inverse, and the input of f will be the output of f inverse. And therefore, x is the output of f inverse, and y is the input. So if we rewrite that, we have f inverse of y gives us the value of x. We just decided that x is equal to log base 7 of y. Therefore, we could take out this middle piece, so just ignore that piece right there. We can write this as f inverse of y is equal to log base 7 of y. And therefore, we know the function inverse for this original function f. If f of x equals 7 to a power of x, then f inverse of y will be equal to log base 7 of y. Let's look at one last example. So consider the exponential function f. Some input-output pairs for f are shown in the table below. So we have x, the input to f, on the left column, and then the output in the right column. So on the left column, we see that we have increments of x of 1. So x is increasing by 1 from each row. And each time x increases by 1, notice that our output becomes 5 times as large. So each time x changes by 1, y becomes 5 times as large. And therefore, we have a 1 unit growth factor of 5. Also notice that we know an initial value for this function. We know that when x equals 0, y is equal to 1. So we can write a function definition for f. We could say that f of x is equal to our initial value, which is 1, times our 1 unit growth factor, which is 5, raised to a power of x. 1 times 5 to the x is just equal to 5 to the x, and therefore f of x is equal to 5 to a power of x. Now, if we wanted to know the function inverse for this function, so if we want to know a function definition for f inverse, we could probably do that. So recall that f inverse will take the output of f as its input. So the output of f is y. Y is our output of f. So y becomes the input variable for f inverse. If we do a little scratch work, we see that y is equal to 5 to the x based on our function definition for f. And therefore, x is equal to log base 5 of y. So f inverse will take y as an input and output x. But we know x is equal to log base 5 of y. So if we erase that middle piece, we see that f inverse of y is equal to log base 5 of y. And that's our function inverse, or the formula for our function inverse, for this function f.